Hi and welcome. I'm trying to learn electroengineering, today energy and power, and afterwards we're going to do medial plane training. And if you participate in the medial plane training, that's at your own risk. Now it's already part 2 to energy and power. And we know that things like toasters, microwaves or boilers use energy and transfer it then to heat, light or sound or movement. And the power is measured in watts, and the power tells us how much electrical energy is transferred in a second. It's transferred in a second, and power is measured in watt, and 1 watt is 1 joule per second. And to know how much energy something used, we have to calculate the power times the time. If something has now 800 watt, like a toaster, that means 1 watt equals 1 joule per second. That means that the toaster uses 800 joules per second. It takes 800 watt, and 1 watt are 1 joule per second. So if a toaster runs for 1 second, that means it has used in 1 second 800 watt, which are 800 joules. Energy E is measured in joules, J, then the power is in watts, and the time T is in seconds. So seconds. Kilowatt hours, when the power is kilowatts, and the time T is in hours. So joules is in watts, and 1 watt is 1 joule per second. And kilowatt is when it is in kilowatts, in 1,000 probably, and when the time is when in hours. Joule to watt are 1 watt is 1 joule per second. Kilowatt is probably 1,000. That means 1 kilowatt are 1,000 joules for 1 second. Now, what I see here is that the joules are measured in seconds, and the kilowatt in hours. Joules to kilowatt is times 1,000, but seconds to hours is not times 1,000. That's times 3,600. I'm just wondering, does it make any problems with the calculation of the comparison of these dates? But example, a 300 watt electric pump is switched on for 1 minute. So we're not going to use visualization. 300 watt switched on 1 minute long. 300 watt. We're needing watt. So 300 watt, 1 minute, 60 seconds. If the thing has 300 watt, that means it has cost in that 1 second 300 joules. In 60 seconds, now 300 times 60, so 5,000. 300 times 6 are 1,800, so 18,000. It has used 18,000 watts, so 1.8 kilowatt. Then let's keep playing with it a little bit. 300 watt for 1 minute, 300 watt for 1 second are 300 joules. Times 60, 18,000. Watt has it cost, and 1,000, and 1 kilowatt or 1,000 watt. But energy is measured in joules. It's the same, it's 18,000 joules. Or 1.8 kilowatt hours. Okay, let's look here. Yes. Energy is 300 watts times 60 seconds equals 18,000 joules. And we're using kilowatt hours when the power is in kilowatt and the time is in hours. Now, are 18,000 joules 1.8 kilowatt? Or is it not because seconds to hour is not times 10? It's not a... How to calculate kilowatt hours in joules in kilowatt hours is the question, basically. Okay, next question. 2.2 kilowatt kettle used for 10 minutes. T is in hours. 2.2 kilowatt does it need? And it's going for 10 minutes. But it's in hours. So we have to change one of them now. So 0.6. So 0.16 of an hour. That's the job. If it was 1 hour, it would use 2.2 kilowatt. It runs a 6 of 2.2, so around 3.5. 3.6. Yes. 2.2 times 10 divided by 6 equals 0.37. 3.5. Yes, a 6. I made it better. 0.3. It is a 6 of 2.2 kilowatt. So if it would be 2.4, it would be 0.4. Now it is 0.37. Okay. I now through it understood all what is written here. But I'm not able to repeat the thing if I get new answers. And I think there is something very interesting that I noticed with. I understood completely all the examples. I was able to do both examples, but I will probably not able to repeat what I just did here. And that is, I think, something very interesting. To learn something about the process of learning. That means we will come back and we will repeat it completely again. Now we're going to do the middle plane train. If you're here for electroengineering, you can go directly to the next video. We will do here now the middle plane train. If you participate, this is your answer. We're doing a greeting muscle. Leg up and bring the foot up and down, up and down. And the other one up. And the foot up and down. And the crane, foot is the ankle taking, straight back and knee down to the floor. And the other leg at the ankle, straight back and foot down to the floor. And now one leg up, riding with the leg, flex foot, inline hip solid with the back, and be pressing from the top against the knee. And we're pressing on the inside. It makes sense that 1 watt is 1 joule per second. But a kilowatt must be 1,000 watt. So that thing needs 2.2 kilowatt, which means that thing needs 2,200 watt. But now I'm confused with the second thing. With the second thing. That means that thing needs 2,002. But kilowatt hours are measured in hour. You cannot just say we said 2,200 joule per second. Or can be 2,000 joule per second, 2,200 watt per second. Now 2,000 per second is not the same as 2 than a kilo per hour. I don't know. We skipped a bit of exercise, but I know what to do. We're pressing up on the top. And from the inside, riding with the leg flex, putting the hip solid back. This is better than it was. Now you press. And the last exercise, the heavy swing door. Leg up, riding with the leg flex, foot even hip solid back, and we're pressing from the outside. And we're opening slowly. And we're closing. And again opening. And closing. And the third time. And with the other leg. Leg up, same setup, and pressing on the outside. And we're opening slowly. Closing again slowly. Open again slowly. Closing again slowly. And the third final time. The ending. Breathe in. Out. And breathe in, close the legs. And out. That was a media plan training. I thank you very much, and until next time.